This video is going to cover Unit 24, Section 1 and 24, Section 2. 24.1 talks about different types of polygons. And if you look at page 597 in the middle, they give you several different types of polygons. And the main thing I want to focus on right now is the difference between convex and concave. A convex polygon is one in which no side cuts inside of the polygon. So something like this right here. So this would be a convex polygon. A concave polygon is a polygon in which one or more of the sides cuts inside of the polygon. So right here we've got this point right here. These two sides cut into the polygon, and it happens a little bit more, or just a little bit right there. But this one's there's a lot, and this one's just a little bit. But both of these sets of sides cut into the polygon. So this one is concave. So it makes a cave, if you can think of it that way. Most of them that we are going to deal with are going to be convex. All right? So there's a couple more definitions there at the bottom of page 597. We have an equilateral polygon. An equilateral polygon is a polygon in which all of the sides are the same. All right? And then we have an equiangular polygon, and that is one in which all of the angles are the same. And then we have what we call a regular polygon, and that is one in which all of the sides are the same and all of the angles are the same. So let's take a look at page number 598, some examples of these. Okay, so we've got this figure right here. I don't know if you can see it there. So each side is side S. So all of the sides here are the same. And it's extremely obvious that all of the angles are not. So this is an equilateral polygon. Okay? So looking at the next one, we can see that all of the angles are labeled as angle A. So they're all equal. But it's quite clear that this side is shorter than this side. So all of the sides are not the same. So this is an equiangular polygon. Now the next one, right here, labels all of the sides as S. So all the sides are the same, and it labels all of the angles as A. So all of the angles are the same. So this is a regular polygon. All right? So we have different names. Some of them are right here. A quadrilateral is quad, meaning 4. So this is a polygon with 4 sides. A pentagon is one with 5 sides. A hexagon is one with 6 sides. An octagon is a polygon with 8 sides. So an octagon, that would be a stop sign. A hexagon, that would be if they added another wall to the pentagon. That's why they call the Pentagon a pentagon, because, I don't know, you may have or may not have seen pictures of that, but it is a 5-sided building. The main buildings or main sides on the outside are all, that's 5. It's a polygon. I think it might be even a regular polygon. Okay? So continuing on, let's look at the top of page 599. These pages are all falling out, so I can just take them right out. Okay, so what we have to do is identify each polygon as equilateral, equiangular, or regular. And then name it as a quad, a pentagon, hexagon, or an octagon. Okay, so this first one right here, all of the sides are 3 inches. It doesn't say anything about the angles, so I can only call this one an equilateral polygon. and also it's got 5 sides, so that would be a pentagon. So this one right here, all of the angles are 180. So this is an equal angular polygon, and we have 5 sides, so this is a equal angular pentagon. And this one, all of the sides are 6, so it's equilateral. All of the angles are 108, so it is equal angular, so that makes this a regular polygon, and it has 5 sides, so it's a regular pentagon. Now this one right here, let's see, all of the sides are 5, so this is an equilateral polygon. All of the angles are 135, so it's equal angular, so this is a regular 8-sided, so that is an octagon. So let's take a look at this one right here. No numbers given at all. However, we know that these symbols right here mean 90 degrees. So all of the angles of this polygon are the same. So it is equal angular, and there's 4 sides, so it's a quadrilateral. So this is an equal angular quadrilateral. This is an equilateral because all of the sides are 8. So this is an equilateral hexagon. This is an equal angular. Yeah, they don't label any of the sides, so I can't absolutely say. This is an equal angular hexagon right there. So, continuing on, we have types, and we're in 24.2 now. We have types of quadrilaterals. So, let me zoom out just a little bit here so we can see this better. Yeah, that'll work. So, we have a parallelogram. A parallelogram is a quadrilateral, so we're specifically talking about quadrilaterals here, 4-sided. A parallelogram is a quadrilateral in which opposite sides are parallel. Okay, and that's the only thing I can say about a parallelogram. Now, other things might be true too. All of these first 4 things we're going to talk about are all parallelograms because the opposite sides are parallel. So DC and AB are parallel, and CB and DA are parallel. Okay? A rectangle. A rectangle is a parallelogram, but there's more specific things about a rectangle because this side and this side are parallel, and this side and this side are parallel. That meets the requirements to be a parallelogram, but because all of the angles are 90, that's a little bit more of a specification. So it doesn't say anything about the sides, the length of the sides, just that they're parallel. So that makes it a parallelogram, and all of the angles being 90 make it a rectangle. All right, so let's go to a square. A square is a rectangle because it's a parallelogram in which all of the angles are 90. So it is a rectangle. However, it's a little bit more specific because not only are all of the angles 90, all of the sides of a square are the same. Okay, and then we go to a rhombus. Now, a rhombus is a parallelogram because the opposite sides are parallel. All of the sides are the same length, so GE is the same length as HG. So all of the sides are the same. However, the difference between a square and a rhombus is that on a square, all of the angles are 90. In a rhombus, the angles are not 90. Okay? Or not equal. They're not all equal to each other. I think that's the exact definition they give you. But whose angles are not all equal. So they're not all equal. So that is a rhombus. A rhombus and a square have some similar properties, but there's definitely some differences there. So now I want to talk about the other quadrilateral, which is the trapezoid. We talked about a trapezoid before. A trapezoid is a quadrilateral in which two and only two sides are parallel. So here's a trapezoid right here. Side AB and side CD are parallel, and the parallel sides are the bases. Irregardless of whether it's oriented that way or sideways or upside down or whatever, the parallel sides are what we would call the bases. Now here's another type of a trapezoid. This trapezoid is different from this one in that it's an isosceles trapezoid. Now remember what an isosceles triangle is. An isosceles triangle was a triangle where two of the sides are equal. So here in an isosceles triangle, if you could imagine extending both of these lines up until they meet somewhere, looks like it might be up in there, that would form an isosceles triangle. So you cut the top off it and you got an isosceles trapezoid. So this side right here is equal to that side right there. And this line, this base, is parallel to that base right there. All right? Okay, so now, one thing about a parallelogram, let me get this in here, let me zoom in a little bit more. What we're looking for here is we're trying to find side AB, I think side AC. So we're looking for this side and this side. We're also looking for that angle and that angle right there. Okay, so a parallelogram, I didn't mention this, but parallelogram is where you have opposite sides are parallel, but opposite sides are also equal. So if this side is 14, this side is 14. If this side is 8, this side is 8. Opposite angles are also equal. So if this is 82, this one's 82. If this one's 98, then this one is 98. Okay? Okay, so let's move over. I find it easier to move left to right than up and down. So going a little out of order here. Number 11. So we need to find side AC and angle B and C. Okay. So here we have side AC, which is right here. That's because this is an isosceles trapezoid. If this one's 3 feet, that one's 3 feet. Okay? Now, another thing about the isosceles is that this angle and this angle are the same. So angle C is 65. So that would make angle A and angle B the same. So angle B is 115. Okay, moving on right to here. So right here it says determine side E, side EF and side FH. And it tells us that this is a rectangle. So we know it's not showing us that these corners are all 90, but the definition of a rectangle is that they are all 90. So it's also a parallelogram and a rectangle. The opposite sides are equal too. So this one would be 9 and this one would be 25. Let's see what else we're looking for. Angle E. So angle E, now this one's kind of tough because they're not giving us, oh wait, it's got to be 90, right? Because it's a rectangle. That was my attempt at a joke. All of the angles are 90. Okay, so this is a rhombus. So what we know about a rhombus is that it's a parallelogram. So parallelograms, opposite angles are equal. So we're looking for side CD. So we also know about a rhombus that all of the sides are the same. So if this one's 7, so is that one. So is that one. So is that one. So all the sides are the same. We also know that if this angle is 42, then this angle is 42. If this is 138, then that one is 138. Okay? So that is some basic stuff about parallelograms. and some specific things about the quadrilaterals and stuff. So we talked about polygons, quadrilaterals, pentagons, hexagons, and octagons, and what regular means, and what equilateral means, and what equal angular means, and then some specific things about some quadrilaterals.